Good afternoon, sir. Am I
You're
audible?
there. So, are you ready with your presentation, Mr. Pushkar?
Yes, sir. Yes, sir.
Okay. So, let's go ahead with this presentation. The title of the paper is Comparative Investigation of Mode Shapes and Natural Frequency of Low-Rise RC Frame Building. And this paper is being contributed by Mr. Pushkar Sharma and Dr. Tanmay Gupta from JUIT Vaknahat.
So,
So,
is the screen visible?
sorry, what did you say?
Sir, is my screen visible?
Not yet. Yeah, it is visible. Yes, you have presented the entire screen. Yes, okay, it is visible.
Okay, sir.
You may start your presentation.
So, very good
And
afternoon.
after 8 minutes of starting the
Okay,
presentation, I'll announce or I will play buzzer.
okay, sir.
So that means you will get 2 or 3 more minutes to wrap it up, and 5 more minutes will be given for question answer session.
Okay, sir.
Okay, right. Pushkar, you may please start. Thank you.
So, good afternoon, one and all present here. I am Pushkar Sharma from JUIT, a PG student. So, I'll be presenting my paper that is comparative investigation on mode shapes and natural frequency of low-rise RC frame building. So these are my content. So I will start with the introduction. As we all know that 55% of the land area of Indian subcontinent is vulnerable to earthquake forces. So this means that in the past years, there are many earthquakes which have been occurred in India and which has shown the necessity of earthquake engineering in India. So such hazards cannot be prevented, and however, one can minimize their effect by designing the structure as per seismic codes. And we all know that the natural period of a vibration is a very important plays a very important role in earthquake engineering, because it plays a very vital role in earthquake design of new structures as well as for the existing structures. So the analysis evaluation of fundamental period of a building is a laborious task. So we move by to software we perform eigenvalue analysis and Pushover analysis for to have a relative. And we all know that there are many empirical formulae in the seismic codes which are used to for various design for different classes of buildings. And this is my abstract. The objective of the study is to determine the fundamental period of existing RC frame building and to study the various parameters which influence the fundamental period, and to establish a comparative study between core-space analysis and finite element analysis. And these are the parameters which are considered in the study: stiffness, mass, natural time period, and modal mass participation factor. So, and I have used the finite element program, that is Seismostruct, for this study. And the need of study, as we all know that modal analysis is very important to understand the vibrational characteristics. The vibration characteristics such as natural frequency and the mode shapes, which are under the dynamic loading. And it is necessary to calculate the natural frequency in order to prevent resonance. As we all know that when an object is vibrated at a frequency equivalent to its natural frequency, the vibration of amplitude increases significantly, which could lead to irreparable damage. And the prescriptive seismic codes have some limitations and work on certain assumptions. And the actual parameters of the buildings are not assessed as per the prescriptive codes. This is the methodology which I have followed. So first we have defined building parameters, taking the case study of building zones which is located in zone 5. And first we have analyzed is as per IS 1893 2016 part 1. And IS 1893 recommends the use of three methods, that is, first is equivalent static method, second is response spectrum method, and third is time history analysis. So I have performed two analysis from the code based design, and second is then I have moved forward to the finite element analysis, and it is performed in C struct. And then I have compared the results of these approaches. So these are the building parameters which I have taken. The building is a residential building, a three-story building located in zone 5, and the height of building is 3.1 meter. Floor height for each floor it is 3.1 meter, and the total length is 50 meters, and in x direction, in y direction, it is 8 meters. These are the size of columns and beams which I have used. And as we all know that equivalent static method, there are many empirical formulas to calculate the natural time period. Some of them are as follows, and the first formula is taken in this study because it is RC frame building without any infill walls. And as we all know that the time period also depends on stiffness and mass of the structure, which are not included in the above equations. So we move to the dynamic analysis, which takes into account these parameters. And the second is the response factor method. And we all know that in the response factor method, the multi-degree of freedom system is idealized in terms of single degree of freedom system, having a learned mass at each level. And using the basic equation of motion for an undamped free condition, we analyze the structure. And in this, mass and stiffness matrices are calculated and for the equivalent model. And using this formula, the fundamental frequencies are calculated. And in the finite element analysis in seismostruct is basically a non-linear finite element program which I have used in this study. There are many other finite element analysis programs such as SAP 2000 and ETAPS. I have taken seismostruct as it is like in the trend nowadays. People are using in their research. It is proficient in forecasting displacement behavior of space as well as plane frames under dynamic as well as static loading, which takes into account the material elasticity and the geometric in non-linearity. And 8 different types of analysis are performed in this software. I have performed the eigenvalue analysis, and in this software, it uses Jacobi algorithm and Lenkos algorithm to solve the eigenvalues. And I have taken the Jacobi algorithm. So these are the results of the seismic analysis. In the manual calculation, first we calculate the seismic weights and the lump mass and lateral stiffness, and then we create the mass matrix and stiffness matrix, and from these we move forward to further for the response spectral method, where we calculate the mode shapes and mode space coefficients, and these are the comparative values of the fundamental frequency from the three approaches, and these are the values from equivalent static, response spectrum, and seismostruct analysis. And these are the mode shapes from response spectrum method and seismostruct. As we all know that in equivalent static method we get only one value of fundamental time period, and in response spectrum method we get the values equivalent to the number of stories we have. And in seismostruct we can get like n number of values of fundamental frequency depending on the uh, degree of freedom of a structure. So I have taken the degree of freedom in x direction, as in my study the in x direction it is the intense contribution is in the x direction. So these are the conclusion from the study. Indian system code has certain limitation and assumptions which have to be amended in new versions, and there are many parameters which influence the natural frequency of the structure. Some of them are stiffness, mass, and height. And IS 1893 states that the fundamental mode dominates the response of the structure, whereas ground motions are complex, having several frequencies. And the results show that there is a satisfactory error for the natural frequency and mode shapes. And we can say that the seismostruct gave realistic values of natural frequency because Indian code gives a regular mode shape. Thank you.
Okay, thank you, Pushkar, for finishing the PPT well in time. Now I invite questions from the audience if there are any.
Okay, sir.
Is there any question from the audience?
Hi, good afternoon, everyone.
Good afternoon.
Uh, my question is very simple, Pushkar.
Yes, sir.
When we are considering three-story building in
Yes,
numerical analysis, usually we are getting only
yes, sir.
frequencies
Yes.
only. But in Sysmostruct software, we are getting so much frequencies. Why?
Because in the numerical analysis, we idealize the structure. Like
Yes.
we idealize the structure into a single degree of freedom. Like if there are like 6 degree of freedom at a node, at a particular node, but in the numerical analysis we first assume that the mass is lumped at a particular point, at a same point. But in C struct we don't assume that thing. We use every node as it is finite element matter. We divide into a number of elements. So there are 6 degrees of freedom at a particular node. So by that we don't idealize the structure in seismostruct, while in the numerical analysis we idealize it.
So which one is more accurate? What do you think?
So I
Values
think
we
that,
are getting from seismostruct
yes sir,
or from numerical analysis
from
based on
seismostruct.
numerical formula?
No sir, from seismostruct, because it doesn't work on any assumption, and it takes into account the material nonlinearity and the geometric nonlinearity as well, like the softwares we use nowadays. But in a code based design we assume that we assume elasticity. We don't take in elasticity into account, so it can change the values or enhance the values from the software.
But in numerical analysis, is it possible to get the values in all directions or not?
Actually sir, I don't know much about it, but we can, like, if we study more about it, like we can do that by
Okay,
yeah.
okay, thank you.
Well, any other question from the audience? Well, we are happy to see Mr. Dr. Arpit Goyal, who was our student in JUIT.
Okay sir.
He is there in the meeting. He has done PhD in corrosion, I think, from University in USA. Well, dear Arpit, do you have any question here? Well, there's no response from him. Maybe he's away. Okay, Shubham, thank you. Thank you for presenting your research work in this conference.
Thank you sir.
Thank you.
So for next presentation,
Yes, sir.
I'm calling Rahul Kumar Meena. The presentation topic is numerical investigation of wind load on side ratio of high-rise buildings.
So
I think he's
Rahul Meena is there in the meeting. I think he's not there, sir.
yes, sir. So I'm calling the next who is Sahil Yadav. Sahil,
Yes,
are
sir,
you
I'm
there?
here. Yes,
Yes. Your presentation topic is study of behavior of the masonry infill structure subjected to lateral loads. Am I
yes,
right?
yes, sir.
Yes. Please go ahead.
Sir, is my screen visible now?
Yes, yes. Yes, it is visible.
Okay, so thank you for giving me opportunity to present this PPT in front of you all. Good afternoon. My topic for today is study of behavior of masonry infrastructures subjected to lateral loads. I am Sahil Yadav, a graduate student from Delhi Technological University. I did my project under Dr. Shilpa Pal ma'am, which is an associate professor in TTU. So moving ahead with the objective of our project, the aim of our project is to get a numerical study behavior of masonry infrastructure subjected to lateral loads. To get various variations on rigidity of a masonry wall by changing Young's modulus of the masonry infill wall. And the third point is analysis analyzing the effects of spaces with different wall opening on the percentage, and know how the stresses and rigidity varies in masonry and fill wall in presence of lateral loading on one edge. Okay, and the fourth point is study effects of magnitude of concentrated load, lateral loadings on the one edge of the wall. So the introduction for the topic. In the finite element method, structure is divided into many small parts, each one with its own material properties. The software that we are using is Abacus for finite element method. The assembly of these elements and the application of loads and boundary condition gave a result in a system of equations describing the structural equilibrium, which was solved to get the desired result. The boundary conditions used in our model is in scattering, that is, movement in x, y, z direction and the rotation in x, y, z direction are 0. So the finite element method is widely used for numerically solving different equations arising in the engineering and the mathematical modeling. And this study we are using Abacus for our finite element method for solving the behavior of masonry and fill walls subjected to lateral loads. So the methodology, initially geometry dimension of masonry and fill wall were referred as 3.6 meter as length, 3.8 meter as height, and zero point 0.1 meter as the depth of the wall. We also noted the dimensions of the concrete frame, which is zero point 0.4 meter length, zero point 0.3 meter width, and zero point 0.3 meter depth all around the masonry and fill wall. We have taken 6 types of brick with their different material properties that are used to calculate Young's modulus of the wall by using equation. Young's modulus equals to 1085 compressive strength, where EM is the Young's modulus of the masonry wall and FM is the compressive strength of the individual brick. So we are analyzing 5 different wall opening models, which are 0% opening, 30% opening, 45% opening, 45% split opening, and the 50% opening. The 30% opening is because according to SP 1992, that is a maximum opening in an internal residential building, and the 45% because it is a maximum opening that can be uh, done in an external wall of a residential building. As I just said, we are using boundary condition that is encastre, and the applied loads are started from 30 kilonewton from the at the upper edge of the structure. The machine size for both from frame and the wall is 0.1 meter. So the initialization, here you can see the geometry and the dimensions of the model. The load 30 kilonewton is applied on the left edge of the frame, and you can see that length and width of the model. Okay. So the lateral loading, as you can see in our model, the lateral loading is the loading that is parallel to the ground and is applied at the upper left corner of the masonry infill frame. 30 kilonewton load is applied, which is split into 2 concentrated forces of 15 kilonewton applied both on the both of the corners of the frame. Now interaction part, the surface to surface contact type is used in Abacus, and the sliding formation is finite sliding, in which there is a small friction between the masonry wall and the frame, that and the load is also transferred to the masonry wall. And here are all the 5 models that we are using in our PPT and the report. Sorry, as you can see, 0% opening, 30% opening, 45% opening, and 45% split opening, and 50% opening. So here we are gonna discuss the results that we attained from our report. So first result that we attained from our report is effect of Young's model in the masonry infill wall. So we are changing the Young's models in a range of 1 Pascal to 20 gigapascal, the relative rigidity of the masonry wall for increasing Young's modulus. So the graph shows the positive relation between Young's modulus and the rigidity of masonry infill wall. As you can see, the x direction, so the x-axis show the relative rigidity of the masonry infill wall, and the y-axis show the Young's model of masonry infill wall that are increased, and there is a positive relation between Young's modulus and the relative rigidity of the wall. That's the first result that we attained from our report. Moving on to the types of brick that we use in our report. So there are 6 types of bricks: sun-dried bricks, ACC block, common building blocks, second-class bricks, fly ash brick, as well as and first-class brick. And you can see they're increasing compressive strength as well as sense modulus of the wall. So for our project, we are using a macro model. That means the property of brick and the mortar is an homogeneous mixture. So we referred Mr. Saroj, Fauji and Prachand Man Pradhan's work, experimental work for mechanical properties of brick and masonry panel. Where using compressive strength of the individual brick, we can calculate the Young's modulus of the masonry infill wall using equation EM equals to 1085 into FM, where EM is the Young's modulus of the masonry infill wall and the FM is the compressive strength of the individual brick. And as you can see, all the properties of the bricks as well as the compressive strength and Young modulus of the masonry infill wall are there in the table, where the sun-dried brick being lowest in Young's modulus and first class brick being highest in the Young's modulus. So here's the second result, relative rigidity of different bricks. Here you can see that x-axis shows the different types of bricks that we are used and the y-axis shows the relative rigidity of the bricks. So the graph shows a positive relation between Young's modulus and the rigidity of masonry infill wall for our six types of bricks. And hence it is examined that the first class brick produces optimum results. So first class bricks is preferred for further analysis. And you can see in the graph that fly ash brick and the first class bricks almost show equivalent rigidity when compared. So moving on to the next slide. So the effect of opening in the masonry infill wall. So here we are studying the effect of opening when we introduce opening in the masonry infill wall. So the x-axis show the increasing order of opening in the wall, and the y-axis show the relative rigidity of the wall. As you can see, when we increase the opening in the wall, the relative rigidity decreases. We show a downward relation between rigidity and the opening of the wall. And when compared 45% opening with the 45% split opening, as you can see, the 45% split opening has more rigidity than the 45% opening. That is because the stresses that are generated in 45% split opening are divided into different parts. So in our result, the 45% split opening have more rigidity. That is in our case for 11% more rigid as compared to 45% single open wall. So the fourth result, that is effect of loading on the masonry infill wall. This is for the first class brick where with the different wall opening percentages. The x-axis show the increasing order of lateral loading, and the y-axis show the relative rigidity increase or decrease when the load is increased in the increase for the first class bricks. And these different lines represent the different opening percentage in the wall. So there is a positive relation between loading and the stresses induced in the infill wall of the first class brick that results in a decrease of relative rigidity. That is negative relation between relative rigidity and the loading. For our results, for 0% opening wall, rigidity decreases up to 150% when loading is increased from 30 kilonewton to 120 kilonewton. Similarly, for 50% wall opening for the first class brick, the rigidity decreases up to 300% when the load is increased from 30 kilonewton to 120 kilonewton. So here you can see the stress diagram for all our models. The decreasing order in column shows the different types of brick with increase Young modulus, and when we move from left to right, you can see that the opening percentage of the wall is increasing. These are for all the six types of brick and five different types of opening. So the opening percentage versus stress generated in the masonry infill wall as shown in the figure. The column represents the Young's modulus for different types of bricks, and the stresses generated in the structure tends to decrease, that can be visibly seen in these graphs. When we move from left to right, the increasing opening percentage, that is from 0% to 50%, that results in decreased rigidity that can be seen in the graphs in terms of corner crushing or the stresses generated. So here are all the stresses that we attain in our analysis for six types of brick and the different opening percentages. As you can see, for 0% opening wall, the sun-dried bricks have 1.74 megapascal stresses, whereas the first class bricks have 1.14 megapascal stresses. That is, first class brick having less stresses generated when compared to sun-dried bricks. That in terms result in more rigidity of the structure. So for the calculation of relative rigidity, we followed Mr. Neville's work, that is using stresses generated in infill wall with Young's modulus 1 Pascal. Then the percentage increase and the decrease in stresses will be converted in terms of percentage increase and decrease in relative rigidity. So here is a conclusion for our work. As the Young's modulus increases, overall rigidity of the wall increases. Second point, to vary Young's modulus of the wall, 6 different types of bricks is used in India is being used for an overall Young's modulus of the masonry infill wall is calculated, and compressive strength that varies from 2 kN per millimeter square to 10.3 Newton per millimeter square, and the compressive strength varies from 2130 meganewton per meter square to 11,200 meganewton per meter square. So different bricks show different results, and the first class brick gives optimum results. Bricks are compared on 5 types of model with increasing wall opening percentages, which results in reduction in rigidity of a masonry infill wall. 45% opening model is compared with 45% split opening model. The stresses in 45% split model are 11 to 12% less, that is 11 to 12% more rigidity in the structure. This resembles dividing a single big opening into several opening, results in overall increase in rigidity. If the load is increased by 2 times, the stresses also increase by 2 times. That a linear relation between stresses and the loading. But when we increase the load, the rigidity of the structure also reduces. So here are the paper that we follow. And thank you everyone.
Thank you, Sahil, for making a wonderful presentation. I have a question. You did nonlinear analysis or linear analysis?
Sorry, sir.
You did nonlinear analysis or linear analysis only?
So it's a finite element method. We did a linear analysis.
Linear analysis only. Because in input data, you are showing only elastic modulus only. That is representing only linear analysis only. Am I right?
Yes, sir.
So, which kind of interaction you are applying at the interface of frame and masonry infill?
Sir, surface to surface interaction is being used in the concrete frame and the wall. That means there is a certain amount of friction between the wall and the concrete structure. So when the load is applied, the wall is not completely attached to the frame. It can move in all direction.
So for that, you introduce some friction factor over there.
Yes, sir. Contact to contact interaction. That in terms means that there is friction in between those frame and the machinery infill wall. That is decided by the software.
For that, you introduce some friction data, or you directly apply surface to surface interaction?
I directly applied surface to
Predefined that.
surface interaction, and I just selected the master surface and the slave surface. The Abacus software automatically determines the amount of friction that is needed for our calculation.
And if I'm not wrong, at the bottom of your infill walls, you are applying fixed boundary condition.
Yes, sir. Fixed boundary conditions.
But if we are putting infill walls in a frame, in that case, usually we are not having such kind of conditions.
Sir, actually, we have that kind of conditions because the wall is surrounded by the frame, as well as the bottom of the wall is fixed, and the frames are already fixed from the ground. That is why I use both frame as well as the masonry wall bottom for fixing that for using that boundary condition of fixing both frame and the wall.
Okay, Sahil.
Okay.
Now the session is open for Q&A. If anyone have any question. Anil sir, if you have.
Yes, sir. I have only one question, Sahil.
Yes, sir.
So You have not considered means there can be possibility of sliding between the two bricks level bricks, no? You have
Sorry, sir.
directly bonded them, right? Right?
Yes, sir. We can use. There are two different methods that we can use. It
Mhm.
first is macro model and second is micro model.
Mhm.
I am using for this project. We are using macro model, not the micro model. So that is why we referred Mr. Saroj papers for finding the properties of a homogeneous masonry wall that can be found with the compressive strength of individual bricks.
Mhm. So which element type you used for bricks?
Sorry, sir.
What was the element type you have taken for bricks for modeling bricks in finite element model?
Sir, it's a
In
8 node brick.
8 node 8.
8 node brick. Yes, sir.
Okay. So, mhm. So, right. So you have taken one brick as one element, or you have divided that into several elements?
No, sir. I taken a wall as an element, then as an homogeneous element for both brick and the mortar. The
Okay.
properties that I just said, I referred from the Mr. Saroj's work and calculated
Mhm.
accordingly.
Means, don't you think that is just an approximation? Because if you are using abacus,
Yes,
so you
sir.
could have modeled bricks as well as mortar.
So, but I can use that, but my results doesn't require that model, that micro model. I know that the micro model is more efficient in terms of working, but we are here working on relative rigidity, not exact rigidity. That is
Okay.
why I didn't
Right.
use that.
Right. Okay.
Sir,
All right. Thank you.
welcome, sir.
Thank you, Sahil. Now we are calling next presenter.
Yes, sir. So next is paper number 24. Rajesh Kumar. Is he there?
Yes, sir. Am I audible, sir?
Yes, Mr. Rajesh, you are audible.
Okay, am I loading the slides?
So the paper is being contributed by Mr. Rajesh Kumar, Rajni Lakhani, and Ashok Kumar. The title of the paper is Physico-Chemical and Thermal Properties of Lightweight Structural Concrete with Light Expanded Clay Aggregate for Energy Efficient Buildings. Well, Rajesh Kumar, you can start your presentation.
Sir, slides are visible?
Uh, yeah, your screen is visible.
Okay, thank you,
You
sir.
have presented the entire screen.
Okay, sir. So, good afternoon, sir. The topic of the presentation is physico-mechanical and thermal properties of lightweight structural concrete with lightweight expanded clay aggregate for energy efficient buildings. And this paper is authored by myself, Dr. Rajni Lakhani, and Dr. Ashok Kumar. So the outline will be I will discuss about the brief background, what lightweight structural concrete are, need for research to conduct this research study, then followed by methodology, result discussion, conclusions, and advantage. So lightweight aggregate concrete has usually lower density in the range of 1100 to
Yes.
1950.
Rajesh, sir, sorry to interrupt you. If I'm not wrong, your PPT is not visible. Only your screen is visible.
Okay, so
Am I right?
Yes, yes, sir.
sir, wait.
Yeah, you have to open your file.
So now it is visible.
Yes, sir. It is visible now.
Okay, thank you. So should I restart or?
You
So
can
sir,
continue.
You can continue from this slide only.
okay, thank you. So lightweight structural concrete usually have density ranging from 1100 to 1950 kg per meter cube, and basically it reduces the dead load of any structure uh, up to 20 to 50 percentage. It can incorporate silica fume, fly ash, and slag as mineral admixtures, which promotes the pozzolanic reactions and imparts the higher strength. And from various literature, it has been found that up to 10 percentage by weight of fly ash, silica fume, and slag, the development of lightweight aggregate concrete with the density of 1600 kg per meter cube with compressive strength of about 60 MPa has been successfully produced. So in our lab, we have used lightweight concrete using different kind of lightweight aggregates such as expanded perlite, vermiculite, lisa, and scoria. But in this study, I will discuss the lightweight structural concrete that was produced by lisa, that is lightweight expanded clay aggregate. So lisa is a round pellet structure that is produced by sintering of natural clay at temperature of 1200 to 1300 degrees centigrade. And it is hard honeycomb structure, 100% inert, vitrified, and it has resistive property against frost, fire, and good thermal insulation property. It is available in different size fractions ranging from 0 to 15 mm. And the picture that you are seeing is the lightweight aggregate fractions that we have used in our lab. So the need for research was, as India is second largest producer of brick in world, and it makes about 200 million ton.
Again,
The
sorry to
slides are not
interrupt,
moving.
Rajesh sir. Slides are not moving.
Slides. At which slide? I am at slide number 6. Okay, I am reloading this presentation from another system. Can you give me 1 minute?
No, I think you can change by clicking on the left hand side. Slides are visible. If you try to maximize the size, go to slideshow.
Okay, maximize.
Last one. Last one. Go to the presentation mode only, sir.
Presentation mode.
Like this?
Yes.
Yes, simply click this button.
Now it is visible?
No, sir, again.
No. You may try to press Alt Tab. Yeah, otherwise this is how you can go.
Yes.
Yeah, that's fine.
Okay, thank you.
Yeah, there is F5 shortcut. Nivesh has told.
Okay. So should I continue with this framework?
Okay, yes.
Okay. So the number of brick producing unit are more than 1 lakh, and as we know that burning of fuel results in emission of gaseous pollutants and ashes into the environment. Therefore, lightweight structural concrete as replacement of brick by incorporating different kind of waste materials such as marble slurry and fly ash has been developed in our lab as per IS 2185 part 4. Different kind of evaluation in terms of workability, compressive strength performance factor, fresh and hardened density, drying shrinkage, macrostructural characterization along with thermal performance analysis as per ECBC, Energy Conservation Building Code as 2017. There are some target for composite climates. So we have targeted those values that I will discuss later in this presentation. So stone waste in India, about 50 million ton of stone waste is generated. This waste is basically fine powder enriched with calcium carbonate, and as you can see here in the bottom, that this stone slurry is just dumped alongside the road and on the local site, which creates groundwater contamination along with air pollution and choking of drain in rainy season due to unorganized disposal. Regarding fly ash is about 221 million ton of fly ash is being generated, out of which about 56% is being utilized. And the strategy to maximize fly ash is to utilize ash outside the specification in cement as well as in concrete, and enhance level of fly ash addition in cement concrete. So as we know that the benefit of adding fly ash will be as it enhance the pozzolanic reactivity, and which that calcium hydroxide, that is the strength degrading phase in the cement matrix, converts into CSH, and strengthen the cement aggregate paste matrix. So our approach was to develop structural lightweight concrete for floor and roof screeding, along with load-bearing hollow wall masonry block as per IS 2185 Part 2. And the specification and our targets was given in this slide. And the target for raw material, that is minimum and maximum amount of the raw material like OPC, 43 grade, sand and lightweight aggregate are given in this slide. So as per table 4.7, the U factor requirement as per ECBC guideline was 0.40 for wall, and we have followed that. Accordingly, we have designed the mixes to develop structural lightweight concrete. The methodology for the carrying out the work was, firstly, we have visited the slide, we have collected the waste, then we have characterized particle size distribution, chemical characterization. We have followed the mixed design as per ACI 523 third revision. Specimen was made, followed by water curing testing. Basic testing was done, and then advanced testing such as SAM, XRD, TGDTA we have also conducted. Regarding raw material, we have used OPC 43, fly ash, class A fly ash, we have used stone slurry. Lisa, we have used of different sizes fraction, as you can see here in the physical property of Lisa, the specific gravity, water absorption, crushing value, loose bulk density and moisture content we have determined, and chemical properties of Lisa we have also determined. So also we have determined the internal structure of lightweight aggregate using image analyzer in our lab, and we have found that the pore size ranges from 10 to 225 micron, and it was okay as per ACI 523 third revision, in which the recommendation for pore size is given as 5 to 300 micron. So at 3 level, we have done optimization. Firstly, we have optimized Lisa aggregate for improving packing density. Then we have optimized for SP doses and water cement ratio, and followed by cement. And the output target was compressive strength for improving packing density. We have done casting and testing. Then the result shows that our targeted slump value was 10 to 15 mm, and we have found that mix MS3 shows the permissible limit. In mix MC5, the maximum 28 days compressive strength was 24.5 MPa. This was more than 20 MPa, and it was targeted also. The flexural strength value was ranging from 2.8 to 3.4 MPa. Regarding drying shrinkage, mix M5 shows minimum desirable shrinkage, that is minus 0.03%. Regarding thermal conductivity, mix MC5 shows the K value of 0.230, which was less than the other mixes. Regarding now we have selected a mix MC5, and we have replaced with cement, fly ash, marble slurry, and we have found that the replacement of cement up to 15% of fly ash and marble slurry, the microstructure was compact and dense. Through XRD, we have found that the phases, that is hemicarboalbunate and monocarboalbunate, was made by adding marble slurry and fly ash and marble slurry up to 15 to 30%, which promotes the formation of denser microstructure. Finally, in the last, we have determined the thermal performance U value, and through calculation we have determined the U value as 0.31, which was less than 0.40 as per ECBC guidelines. So the conclusion of the study was mix MS3 lightweight aggregate concrete shows permissible slump value. The compressive strength ranges from 16 to 24 MPa with flexural strength of 2.8 to 3.4 MPa, and drying shrinkage of lightweight aggregate concrete of mix MC5 was lower as compared to the other mixes as well as normal weight concrete. So socio-economic impact was, it will contribute to Swachh Bharat Abhiyan by waste utilization. The replacement of natural aggregate by crushed stone waste aggregate will be there, which will and due to that, air, water and land pollution will be controlled. The advantage of lightweight composite that we have developed in our lab as given here. So this work has been conducted in our recent project ongoing, that is Indo-US Science and Technology Forum under grant GAP 0806, And we have also done industry academia interaction with MSRs Rivasha Eco Design Solution Private Limited, and they have funded the research project that is to improve the technology of expanded clay aggregate. And now we are in the process to transfer of technology that we have developed in our lab to this party. These are some references that is followed to conduct this research study. Thank you.
Okay, thank you, Raj sir, for presenting a very wonderful work. It's very interesting and it was comprehensive. You have presented a huge amount of data within a short time, and this need of the hour definitely to produce energy efficient materials. Well, I have a question that have you tested it for durability on this concrete for durability?
Yes, we have tested for freeze thaw resistance up to 50 freeze thaw cycle, and the data are till now not finalized. That's why I'm not sure, but we have conducted a freeze thaw resistance study also.
And the sulfate and chloride attack also?
Yes, these are also sulfate attack and chloride penetration attack we have also tested.
Carbonation.
So, yes, carbonation we have not conducted, but after extension of this project due to COVID, the work is not that is stopped. So further we will do this.
Right. Okay, that's all from my side. Is there any other question from the audience, Dr. Pankaj? Any questions, sir?
No, sir. Thank you, Dr. Rajesh, for a very comprehensive work.
Thank you, sir. Thank you.
Any other questions from the audience? Okay. Thank you, sir.
Okay. Thank you, sir.
Now I hand over to Dr. Pankaj. Yes, sir.
Yes, ma'am. The next presentation is by Salil Jha.
Yes, sir.
Prioritizing building for seismic retrofitting on the basis of rapid visual scanning score. Am I right?
Yes, sir.
Yes, please go ahead.
I hope my screen is visible.
Sir, I need to make an announcement for everyone. Today at 5 p.m. there will be valedictory function for this conference, and best paper award will be announced for every session. So I request everyone to join the valedictory function. Its link will be shared in the chat box shortly. So please join the valedictory function at 5 p.m. today. Thank you.
I hope my screen is visible.
Salil, please continue.
Okay. A very good afternoon to all. My name is Salil Jha, PG student MTech structure from Delhi Technological University. My topic of presentation is prioritizing building for seismic retrofit on the basis of RGS scope. So let me have a brief introduction of what RGS is. RGS being a sidewalk survey offers a systematic approach to pinpoint those structures which could be threat to life in the event of seismic hazard. RGS score is a measure of collapse probability for any building subjected to MCE ground shaking. So RGS score does not cater for shaking levels other than MCE ground shaking. That is either less than maximum considered earthquake shaking or greater than maximum considered earthquake shaking. For that matter, RGS score is then correlated with the risk score, where risk score is the measure of probability of at least one earthquake that during the years that would lead to collapse of the building. Then further, risk score is correlated with the probability of collapse causing earthquake. Now, what is the need of this study? Why do we need to study it? As per the studies conducted in past, it has been stipulated that it is not the earthquake which kills human. Instead, it is the poor and substandard practices involved in the construction of the building. Various IS code of the for the design of building are being overlooked in order to facilitate the rapid urbanization. Therefore, such building needs to be screened at an earlier stage in order to address the vulnerability of buildings. Incorporating the technical parameters available in IS codes such as 1893 and 4326, etc., and confirming them with FEMA P154 2015, a comprehensive scoring strategy for the risk assessment of earthquake causing collapse needs to be developed. Moving on to next slide, which is the case study for probability of earthquake leading to collapse, which is noted by RT. So although we have 17 different types of building as per FEMA P154 2015, but in order to correlate the actual observation on site and risk score, two building types have been adopted. The first is RCC G+3 building. The second is load bearing masonry building. So what methodology has been adopted for the probability of earthquake leading to collapse is being shown in this slide. So at first, we need to identify the seismicity of the zone, seismicity zone as per the IS 1893, and we confirm it with FEMA P154. Then accordingly, we select a data sheet which is given in FEMA P154 2015, and depending as given in that FEMA P154 level 1 data sheet, we assign a basic score to the building based on the type of material and the type of construction it is. So owing to various irregularities present in the building, score modifiers are assigned to the structure, and then the final RBS score is calculated by subtracting the score modifier from the basic score. And a check is being run that whether the final RBS score obtained, which is S or S in our case, is greater than or equal to the cutoff score on level 1 datasheet. If yes, then we calculate if the final RGS score is greater than the cutoff score, then we calculate the risk score, which is denoted by SR. If no, then we adopt the minimum RBS score or cutoff score as given in level 1 data sheet as final score, and then we calculate the risk. To calculate the risk, following formula has been this formula has been adopted by FEMA P155 2015, in which an addition of numerical value of 1 is being added to the final RBS score, and then after calculating risk score, we move on to calculation of the probability of at least one collapse causing earthquake during T years. So that probability of at least one collapse causing earthquake is being calculated by this formula as given here, where SR, as we know, is risk score. This T is the number of years for which we are actually assessing that one earthquake, or we are actually estimating the probability of earthquake, and this tau is the design life of the building. So then we check whether this RT is greater than 1.5, greater than or equal to 1.5 times the probability of occurrence of MCE, which is 3% for 50 years. Now moving on to next slide. If our RT is greater than 1.5 times the probability of MCE shaking, then we perform detailed structural evaluation and adopt global retrofitting measures, as the existing building is 100 times fatal than the new buildings, which means that if the probability of occurrence of an earthquake causing collapse is greater than 3%, then we go for global retrofitting measure, as the fatality of that existing building is 100 times higher. So if no, then we check if our RT is greater than or equal to probability of occurrence of MCE or not. That is 2% for 15 years. If yes, then we perform detailed structural evaluation and adopt local retrofitting measures local retrofitting measures, because at this level of probability of occurrence of earthquake, we have only 10 to 32%, 10 to 32 times the fatality of the new building. The fatality of existing building is 10 to 32 times of new building. So if it is not, if our RT is less than probability of occurrence of MC, then the building is rendered to be safe from earthquake causing collapse for next T years, or whatever in number of years we are considering it for. So following are the results of our case study conducted. As per the study, following results have been obtained. Let us first discuss this RCC G+3 building, in which we obtained an RBS score of 1.4, to which the risk score was calculated to be 2.4, and therefore the probability of earthquake causing collapse for next 50 years got down to 1.57%. That is 1 in 63 chances of collapse causing earthquake to occur. And as the probability of collapse causing earthquake is less than the probability of maximum considered earthquake, therefore the building is prioritized as safe. Moving towards the load bearing masonry building, the final RBS score obtained in this building was 0.5. The risk score obtained was 1.5, and the probability of earthquake causing collapse was obtained as 3.11%. That is, there are 1 in 32 chances that that an earthquake would happen or occur within the 50 years. That would lead to the collapse of this load bearing masonry building. As the RT is greater than the probability as the RT is greater than the probability of MC, therefore the building is prioritized as unsafe for our scope. So now moving on to next slide, which heads as risk score and its inference. So how we are going to infer the risk score we obtain in terms of fatality of existing building. So from this slide, it can be inferred that as the risk score decreases, like as the risk score decreases, then the fatality of existing building increases as compared to new building. For example, if I select an RBS and risk score of 2, then the existing building has 32 times more fatality than the new building. So now move on to next slide. So these are the few conclusions which have been made. So last but not the least, these following conclusions are the gist of the paper. So RCC G+3 building has been rendered as safe as per the preliminary study, because the probability of collapse causing earthquake is less than the probability of MC shaking. Hence, it has not been recommended for retrofitting, as we can see here. It has not been recommended for retrofitting. Moving to the load-bearing masonry structure, the probability of it has been rendered to be unsafe. As we can see here, that this building has been rendered to be unsafe based on the preliminary study, because the probability of earthquake causing collapse was found to be greater than the probability of maximum considered earthquake, which is that is 2% for 50 years, and hence it has been recommended for global retrofitting. Therefore, it can be concluded that on the basis of risk score, a building risk score or RBS score, a building can be prioritized for seismic retrofit. Here are a few of references which have been followed during the course of work, and I'd like to extend my thanks at last to everyone, and I'm open for questions. Thank you.
Thank you, Salim. Any question from audience? Anil sir?
Yes, sir. So, Salil, you have considered the probability of occurrence of failure causing earthquake.
Sorry, sir.
Yeah.
Sorry,
You have
sir.
considered the probability of occurrence of a failure causing earthquake. Means the
Yes,
earthquake
sir.
that can
Yes, sir.
cause
Collapse causing earthquake. Yes, sir.
collapse causing earthquake.
Yes, sir.
So, what is the probability distribution for that you have taken for the earthquake?
So the probability distribution is being taken by this FEMA. It has been supplemented in FEMA P155. The entire calculation has been done by them. The only thing which we have done or which we have attempted in our purview or in our course of work is that whether these methods or whether these practices can be adopted as per Indian standards or not. In our case study or in our research paper, or in my thesis, which I am going to present as my final submission, I have actually tried to attempt or actually tried to correlate the standard Indian standards and the US government standards, and have tried to put forward a basic or simplified version of these standards so that every layman or every civil engineer can use it for their benefit. So this was done. This is the entire intent of my coursework.
That's fine. So, so have you, found some relevance with the Indian scenario?
Yes, sir.
Can we use it?
Yes, sir. Yes, sir. We can use it.
So, how do you validate that?
Sir, using these spectral acceleration values, I have first of all compared them with the intensity of earthquakes. They are considering as a severe, very severe, or moderate or low. So and then I have compared it with our IS 1893 zoning, that in which zone this severe zone falls, or whether it falls in zone 5 or zone 4, or it is overlapping with zone 4 or zone 5. So I've done that, and all those parameters which has been given in the level 1 data sheet for masonry building, I have actually tried to compare it with IS 4326, which is actually for the repair and rehabilitation or earthquake resistant structures for masonry, earthquake resistant design for masonry structures. So I have actually tried to attempt to compare all of them and try to put forward a simplified version of everything, of both the things. I mean.
So, have you considered the uncertainty in the input parameters, like
Yes, sir. Yes,
that for the buildings?
Yes, sir.
In case they have uncertainty in materials, in geometry, or in their
Yes, sir.
irregularities, or even deterioration in materials?
Yes, sir. Sir, various irregularities such as if I talk of plan irregularity, then the reed bend corner.
I'm talking of uncertainties in those input
Yes, sir.
parameters.
Yes, sir. I have actually decreased the risk score by 25%, so that the various uncertainties such as any damage caused to the interior of structure, which could not be which could not be inspected during the rapid visual screening, has been accounted for, or if there is any kind of a crack which was there but has been repaired by the authority or by the management, but it is there present. So I've actually tried to incorporate each and every uncertainty, and using for different zone factors, we have used different uncertainty factor. For example, if I talk of zone 4 and 5, then I have used 25%, and if I talk of zone 2 and 3, then I have used a factor of somewhere it is upon discretion, so I have left it in somewhere in between 10 to 15%.
Okay.
Totally upon the discretion of the screener or the engineer in charge.
Okay. So you have used a FEMA procedure to solve your problem, the objective you have decided.
Yes, sir. It's actually the amalgam of FEMA procedures, Indian primers, and the ATCs are also being observed. ATC is a code which has been observed, and ASCE 310, which states that how a detailed structural evaluation should be considered and taken for. So various foreign and Indian standards have been followed in the entire process.
Okay, thank you, Salil. Thank you for presenting your work here in the conference.
Thank you, sir.
It is nice work. Okay, thank you.
Thank you, sir.
Pankaj, sir, that's all from my side.
Okay, sir. Shall we go next?
Thank you, sir.
Sure, sir. Let me see who is present next. Right, sir. Praswal Madgay is there?
Yes,
or,
sir.
Rajan
Himanshu is, from my group, Himanshu is presenting.
Himanshu.
Yes, sir. Present.
Okay, we have got your two names, Praswal and Rajan.
Yes, sir. We have only two names, Prajwal and Rajan Wankhede.
Okay, right, sir. So who will
Rajan sir, your mic is mute.
okay?
Sir, please
Now,
unmute Rajan sir.
right.
Okay, so Himanshu is going to present now for our paper.
Okay, okay, sir. So, okay, I call upon Mr. Himanshu to
Yes, sir.
present the paper, which is being contributed by Prajwal and Rajan sir. And the title of the paper is Use of Waste Polymers in a Plastic Bricks.
Yes. Can I present the screen, sir?
Bricks as Sustainable Building and Construction Materials. Am I right, sir? This is the paper you have contributed.
Sir, yes.
Yes, sir.
So there are three authors, right?
Sir, we have 5 authors.
Okay.
We have 5 authors for this.
Okay.
And
Okay.
we are having the list on presentation also.
Right. Right. Okay. That's fine. So, Himanshu, you may please start. Share your screen and start. You have 10 minutes in total, plus 5 more minutes for question answer.
Sure, sir.
Okay. Right.
Sir, is it visible?
Yes, it is visible.
Good afternoon, everyone. A warm welcome to everyone. I am happy and lucky to being a part of this organization and research conference. Me, Himanshu Berat, along with my co-authors and colleagues as co-authors, along with my teachers, are Prajwal Madge, Abhijit Roy, Nishan Vaidya, Nivesh Sakarwade, and our teacher Rajan Wankhede are going to present this presentation on the topic of use of waste polymer in plastic bricks and sustainable building construction materials. Our project is basically a brick composition which are used in the construction designs and which is made using the cement, fly ash, fine aggregates as well as plastic materials, mainly LDP and SDP. So going along with our presentation, this is brief about our project. We basically use thermoplastic material in our constitution and ingredient, in which we use LDP and polyvinyl chloride as a plastic material. We majorly try to decrease the amount of fly ash and cement, which are the binding materials, to reduce the cost. Even though we are using the mixed designs, we have to use it in proper proportion, because using it in proper proportion only gives us the required strength. So we perform various mixed designs in this, and and by performing our project, we see that by varying these proportions of the LDP, cement, and other materials, we can vary the range of properties which are going to obtain by our prototype. The results are further displayed in our PPT, and optimum content is also explained. So going with our PPT. So firstly, I will explain that what is the things that motivate us to research in this field. The major factors are we try to recycle the plastic waste, which is increasing day by day, and we also want to find a cure for the deterioration of natural soil, which is also used in traditional bricks for its making. So these are the two major factors which motivate us. But along with that, we try to overcome the flaws of traditional bricks and try to cope up with the changing construction demands with an economical cost, since it is most important nowadays. Our plus point is we also use the industrial waste fly ash in our prototype, or we can say in our brick. Now in next slide, you can see the method of preparation. This is the whole sequence of our procedure, and I will try to keep everyone on this track. Our PPT is also in this format. You can see, firstly, when we start, we try to collect our materials, and then how we mix our materials, then what testings we are done, and finally overall the results. This is the flow chart of their sequence. So going with this, our PPT, you can see, firstly, for every project we have to collect the material. We have cement, fly ash, and fine aggregate with us, but we have to find what plastic we are using in our brick to vary the properties by our side. So we firstly, for knowing more about this plastic and this proportion, we visited the Kalamna plastic industry situated at Nagpur. So they gives us brief about how plastic is shredded and how it is mixed, and how we can use it in our mixed design, since there is no proper mixed design of such a cement, plastic, and aggregate containing bricks. So we take a brick from that, and we use shredded plastic in our design. So now in the screen you can see some machineries which are used for making that shredded plastic, such as circular grinder, plastic sieve, shred container, and in the middle picture you can see the aglo, which is a pre-sieving form of our plastic. And after sieving we can get the shredded fine plastic. We use 75 micron sieve, but there are various variations also where we can use 45 micron sieves also. Basically, we are use this 75 micron sieve by taking the consideration of soil classification. In next slide, you can see mixed proportion we use. So these are basic ideal mixed proportions and successful mixed proportion by us. Since we perform the number of slides and number of trials, so we can't display everything in this PPT. So we only displayed ideal and successful proportions. You can see in this table that cement content, plastic waste content, fine aggregate, and fly ash are varying according to various content and proportions, in which fourth and fifth composition we use LDP, SDP, and PVC in 10-10%, while in other compositions we only use PVC. And then we do casting and other processes. We generally cure our bricks for 1 week, since we have to perform multiple trials and we can't wait for 1 month total strength. So only we perform it for 1 week strength. Now in next slide you can see the photos of our molds and plastic bricks after casting, before casting, and our final product photo. This is actual photo of our final product. While casting, we seen that in 13% and 11% of cement content, we got the proper binding and shape of that brick. So this is the photo of 13 and 11% of bricks in different molds. So going along with that, after getting our prototype brick, we have to test it. Since we got the multiple samples of our bricks, but we have to analyze it that either it is fitted our criteria or not. So we decided to perform various tests from that. We majorly perform 3 tests, which are given in the slide, such as a crushing strength test for strength of the brick, and water absorption test to find its dampness and moisture absorption capacity. Also, we perform hardness test on bricks to find the hardness of our prototype, and also is it able to bear the wear resistance or not. So after that test, we got various results of our trials. For every test, we generally take 3 to 4 samples of every mixed proportion, since we have to find a mean to find exact analysis of that prototypes. So after finding that analysis and that results data, we have to compare our bricks in existing bricks with existing bricks in market, which are normal cement bricks. So we compare our data with normal cement brick data, which is given in the slide. That a normal brick have a compressive strength of 9.8 Newton per mm square, water absorption of 14 to 15%, and density of that brick is 1.8 to 1.9 gram per cc. So to get the better analysis, we compare our data in graphical form also, which are shown in the further slides. These are the data of our prototype bricks and sample bricks. This is also ideal and successful compositions. You can see the compressive strength test data, water absorption test results, and density of bricks, which are varying along with the compositions we use. So these are the graphical analysis of our strength test. First one is compressive strength test of normal bricks are compared with our bricks, which are shown in the orange bar graph, and the right one is water absorption test results, which are compared along with the different compositions. This gives us better analysis to find out the optimum compositions, and we have to find out our optimum composition to finalize our result. In next slide, you can see the density of these both bricks are also compared, and we got to the result that composition number 5 gives us optimum result within economical cost and efficient strength. So we confirm our efficient composition is composition number 5, and which is shown in the pie chart. The cement contained, waste plastic, fine aggregate, and fly ash compositions are also shown in that along with their percentage. So after these results, we came to know that our project have various benefits, such as due to their low density, it's a solution to structural components used in earthquake-prone regions. Since it have low density, it can reduce the dead weight of the structure, which is very efficient in these earthquake-prone regions. Also, plastic. We everyone know that plastic have natural ability as a non-conductor of heat. So our bricks can maintain the constant internal room temperature in even in extreme outside conditions, such as extremely chilled and cold conditions. So it is very beneficial in army boot camps condition. It is also economical in cost, and due to less moisture absorption capacity, it is easily using water retaining structures. Also, it reduces the chances of cyclic salt cracks and freeze conditions of our bricks, and the faults which occurs due to extremely chilled conditions. After that, we came on the conclusion that our composition number 5 gives us desired results in the case of mixed proportions, less density, water absorption is also less, and higher compressive strength. It is also economical in cost rather than the normal bricks. It is observed that when we use the polypropylene rubber composite, we get the 13.25 Newton per mm square as our compressive strength, and when we use LDPE rubber, we get 12.01 Newton per mm square as our compressive strength, which is much higher than the fly ash brick, which we taken as analysis. It only have 9.82 Newton per mm square. Our bricks are also the cure for the recycled plastic uses. The plastic waste is also reduced in this technique, and we only use shredded plastics in this, since there are other methods also where we can use the plastics, such as melting, but melting emits lots of greenhouse gases, and we don't want to pollute another natural factor such as air and water to finding the cure for the one. So we only go with the shredded plastic one, and it gives us optimum results also. So this is from all our side. Thank you for giving us chance to present. Thank you.
Well, thank you, sir, for presenting your work in this conference. Well, this is indeed a very good work, and you have found new ways to use plastic waste. Well, I have got a question to ask that have you studied its durability of this material, and what about the fire resistance of plastic, because it is ultimately being used here, and it can easily catch fire as compared to conventional bricks. So kindly comment on this.
Yes, sir. We have work on the durability of its structure. So it is kind of durable, and we try to find out the fire resistant solution, but we don't got enough time to find out that due to COVID situations. So that fire resistant test is still remaining in our project. So that's why I don't explain it in this PPT.
Okay.
Even while construction of the masonry, 1 centimeter or 10 mm, minimum 10 mm of a plaster is applied on the brick wall. So if plastic brick is inside the plaster, so it is automatically it is safe from fire by some percentage. We can consider this point also.
Yes. But there are some cases when people like to keep their walls exposed. Generally, there are some from aesthetic point of view, plastering is avoided in some cases. But anyway, if you are going to conduct this, fine. For fire resistance of this material.
Sure.
Yes, sir. Yes, sir. In upcoming days, we definitely going to conduct this test. But we use the plastic in crushed form, and it is in inside brick. So maximum amount of portion which is outer surface of bricks are covered by cement aggregates and flash also. So fire is that not that much concern for this brick.
Right. So you mean to say between the plastic chips there will be concrete and sand?
Yes.
Okay, that will prevent continuation of fire. Right. Okay.
Yes, sir.
Right, sir. Is there any other question from the audience?
Himanshu, I have a very simple question. How you are ensuring homogeneity of concrete? Because if I'm looking into the density of plastic waste, it is quite less as compared to other material of concrete or ingredients of concrete.
Yes, sir. Sir, homogeneity, sir, we perform mixed designs for that. And homogeneity of concrete, we can determine it by the pores and the binding of that bricks. That's why we perform the water absorption test also, so that to ensure there are not so much many pores in that brick and lot much water is not absorbing that.
But during mixing of all ingredients, usually what we are getting, usually plastic waste is usually we are filling at the top of mix only.
Yes, sir. But we using 75 and 45 micron, which is like a clay soil. So we have to use it along with the cement and fly ash also, so that it can properly mix and bind together. We can't use it in the outer surface. Otherwise, it will spread up.
Okay, one more thing. In one slide, you are presenting data of normal cement bricks, where you are
Yes,
writing compressive strength of cement is around 10 MP and water absorption is around 15%.
yes, sir.
These data are for brick, matlab clay brick only or for cement brick?
Sir, it
Fly
is
ash
a
brick, sir.
fly ash brick, cement fly ash brick.
Okay.
Any other
Thank you.
Is
question?
That
there
is all
any
from
other
my side.
question from the audience? Well, I don't think there is any other question from the audience, sir. I think Pankaj sir, you can take up the next
Yes,
one.
yes, yes, sir.
Thank you, sir.
So next
Thank you.
presentation is by
Sorry to
Maninder,
interrupt,
Maninder Singh. Maninder is here. I think he's not here. And next one is Abhishek Srivastava. Abhishek, are you here? Yes.
Yes, sir.
Yes. The title of presentation is Physical and Mechanical Characteristics of Cement Mortar with Coal Bottom as Fine Aggregate under Elevated Temperature. Am I right? The paper
Yes, sir.
is co-authored by S.K. Singh and Rajesh Kumar.
Yes, sir.
Yes, please go ahead.
Sir, my slide is visible.
sorry to interrupt, Abhishek. Meanwhile,
Yes, sir.
I would like to announce that at 5 p.m. there will be valedictory function. Please be there because best paper awards will be announced for every session. So link will be shared in the chat box very soon. Thank you.
So, shall I start?
Yes, please.
So, good afternoon, all the professor in chair and all the fellow researcher. I am Abhishek Srivastava from CSIR Central Building Research Institute. The topic of my today's presentation is physical and mechanical characteristic of cement mortar with coal bottom ash as fine aggregate under elevated temperature. As we know that coal bottom ash is a waste product produced from thermal power plant. We have used it as a replacement of natural sand and fine aggregate in cement mortar and investigated its behavior and performance at elevated temperature. So the outline of today's presentation is introduction, then objective.
Sorry, Abhishek, it seems your mic is at some distance. Your voice is, we are getting your voice at very low pitch.
Hello, is my voice is visible, audible? Hello.
Yes, now.
Thank you, sir. The outline of the presentation is the introduction, then objective, experimental program, results and discussion. Then based on the experimental data, we have proposed the empirical equation to predict the residual compressive strength of CBA mortar, and then the conclusion and the references. So as I have mentioned that the CBA is the byproduct produced from thermal power plant. As we know that today's modern generation is based on the electricity. Without electricity, there is nothing. And there are many methods to produce the electricity, and the major constituent of that is by thermal power plant. In thermal power plants, and this is the schematic diagram showing the production. So in thermal power plant, coal is used as a fuel for boiling the water. during the burning of coal in the thermal power plant, two type of ashes are produced: the bottom ash and the fly ash. Bottom ash are collected at the bottom of the boilers. That's why they are named as bottom ash, and the fly ash is collected at the bottom of the precipitators. Fly ash is widely used because of its fineness and its pozzolanic properties. Indian standard has allowed the 15 to 35% of utilization of fly ash in making the concrete. However, due to the higher particle size of bottom ash, they still being dumped into the landfills without any recycling. In India alone, 30 to 35 million tons of CBA is produced annually, and it is dumped into the landfill. Due to the dumping into the landfill in the form of making the slurry, coal ash pond, the heavy metals present in the coal bottom ash, they leach out to the surface water, and they contaminate the river bodies. Also, the people lying near these coal ash ponds are having a problem of pulmonary vesiculates in their lungs and hypertension in the living organism. So the dumping of the CBA into the landfill is not a good option, and recycling of CBA is the need of hour for its safe disposal. And the utilization of CBA, many researchers were investigated due to its particle size similar to natural sand, has done a lot of research on utilizing it as a replacement of natural sand in mortar. Performance of mortar with CBA at ambient temperature is well studied by various researchers like Torketikul et al., Batty et al., Ramados et al. In India, Rafat Siddiqui sir from Thapar University and Navdeep Singh from NIT Jalandhar have done a tremendous work in CBA-based mortar and concrete. However, in the literature, no study has been reported investigating the behavior of CBA mortar at elevated temperature. So this research gap is tried to fill in this research study. So the objective of the present study is to investigate the behavior of CBA mortar at elevated temperature. We have prepared the experimental program involved preparation of cement mortar CBA based mortar mixes of binder to fine aggregate ratio of 1:4, and then the specimen were exposed to different elevated temperature from 200 to 800 degrees Celsius in step of 200, and after exposure they have been examined for mass loss, UPV and compressive strength. Furthermore, empirical equation is proposed to predict the residual strength of CBA mortar at different elevated temperature up to 800 degrees Celsius. First, the material in experimental program, the first is the material. The material used in the present study are the OPC, natural sand, and CBA. And the standard OPC is the OPC 43 grade, so IS as per IS 8112. Then in natural sand is IS 383 and CBA. I have written IS 383 for CBA also because the grading of the CBA is made comparable to the natural sand, which lies in the zone 2nd of IS 383. Then the specific gravity is this, and 3.15, 2.56, and 1.87, the fineness modulus of natural sand and CBA. These are the two pictorial representation of natural sand and CBA which is used in the present study, and these are the SAM images of CBA and natural sand. You can observe here that the natural sand, the surface part of the natural sand is solid and the smooth compared to that of CBA, which has the rough surface structure and the porous structure, which has its impact in the various properties of the cement mortar, which we will discuss in the further slides. So the mix proportion, the flowability of the mortar mix has made fixed standard as per IS 2250, 110 to 115, and the flowability of the mortar was estimated using ASTM C1437 code as per the procedure of ASTM C1437. This is the mix proportioning of different material. Sample preparation involves the mass loss and the compressive strength. For estimating the mass loss and compressive strength, 50 mm cube are used as per ASTM C109, and UPV test was done on the prism bar of size 14 to 160 mm size. This is the heating cooling regime. We have used the high temperature furnace. I have shown this. This is the Carbolite Garrow of electrically operated programmed high temperature furnace having heating capacity of 1800 degrees Celsius. This is the facility we have in our CBRI. So it is a programmed furnace. So we have exposed the specimen at initial heating rate of 5 degrees Celsius per minute. After the target temperature is achieved, the temperature is held for 1 hour so that the uniform temperature heating of the sample occurred. After that, the samples were allowed to cool down at 2 degrees Celsius per minute. This is a testing procedure for workability and flowability test. The flow table test of Anil company is used. Compressive strength is estimated using 1000 kilonewton UTM, and the UPV is used. The UPV is estimated using the Prosec Pondit UPV tester machine having transducer of 54 kilohertz. So these are the results and discussions. And the first one is the workability. Actually we have fixed the flowability of the mortar mixes. So the water demand to attain the standard flow is quantified in terms of water cement ratio, and you can observe that the water demand of the CBA mortar mixes are more than the natural sand. This is attributed due to the porous particle and the rough surface texture of the CBA particle. Due to the porous nature, the water present in the matrix system is absorbed by the particle, and due to the rough surface texture, the friction between the particle increases, and due to this, the overall reduction of flowability occurs. Now this graph shows the mass loss result, and you can observe that at 200 degrees Celsius, the mass loss ranges from 2.1% to 4.35%. Due to this mass loss occurred due to elimination of free water present in the void of the specimen. CBA mortar shows higher reduction in the mass loss due to greater water content. At 400 degrees Celsius, the reduction in mass loss is attributed due to the commencement of dehydration of calcium hydroxide and CSH, and elimination of chemical water. At 600 to 800 degrees Celsius, that is at higher elevated temperature, mass loss is due to decomposition of calcium hydroxide and calcium silicate hydrate. These are the hydration products. Now the UPV results, you can observe that as the elevated temperature exposure increases, the ultrasonic pulse velocity of the both the NS and CBA based mortar mixes reduces. At 400 degrees Celsius, the natural sand boys mortar show 9.8% reduction in UPV, while CBA show 20.4% reduction. This reduction in UPV value is attributed due to loss of free water and chemical water at up to 400 degrees Celsius, which lead to the empty voids. And as we know, as is a traditional wisdom, that the velocity of ultrasonic pulses reduces while passing through the air medium air medium. A sharp reduction at 600 and 800 degrees Celsius was observed. This is attributed to the increased porosity caused by the more internal cracks caused by the decomposition of calcium hydroxide and CSH. This graph shows the results of compressive strength, and you can hear a peculiar trend was observed. As you can see that up to 400 degrees Celsius, the CBA mortar show better performance. At 200 degrees Celsius, you can see that CBA mortar mixes exhibits 81% of its initial strength, while natural sand exhibits 70% of initial strength. However, at 400 degrees Celsius, comparable behavior is observed. However, at higher elevated temperature, the strength of CBA mortar mixes are lower than that of natural sand. This is because of the higher porosity of CBA mixes, and as we know that the porosity bears the inverse relationship with the compressive strength. So due to the higher porosity of the CBA mortar mixes, the residual strength of mortar mixes at elevated temperature is low. Empirical equation. Then based on the experimental results, an empirical equation is proposed to estimate the compressive strength of CBA based mortar at different elevated temperature. All the data points are merged together, and through regression analysis, an equation is proposed in which the residual strength is the dependent variable, and the exposure temperature is the dependent variable or the predictor. The coefficient of determination for this equation is 0.99, which is very close to 1, which signifies its applicability. To further justify the reliability of this equation, the experimental predicted compressive strength result was plotted against the experimental compressive strength result, and as you can observe that the data points are very close to similarity line, which further signifies that this equation can be used in the post-fire analytical study of CBA-based mortar. So based on the above study, the conclusions are the water demand of CBA mortar was 57% higher than the NS-based mortar for attaining the standard flow. CBA mortar showed 27.07 to 45.27 higher mass loss compared to NS mortar. Residual behavior of compressive strength of CBA mortar is better or comparable up to 400 degrees Celsius. However, beyond 400 degrees Celsius, strength loss in CBA mortar was higher. UPV values of CBA mortar specimen were 9.2 to 28.15% lower compared to natural sand mortar. An empirical equation is proposed in this research study having higher coefficient of determination with R square greater than 0.9 to predict the residual compressive strength of CBA based mortar being exposed to high temperature. This is the acknowledgement of National Building Construction Corporation Limited. We are very thankful to them for their financial support under the project grant of GAP 0018 to our CBRI or my head, Dr. S.K. Singh sir and Rajesh Kumar sir. These are the references. Thank you very much and Jai Hind.
Thank you, Abhishek, for this presentation. You have shown a very good utilization of coal bottom as fine aggregate in concrete. You have
Thank
conducted
you,
this
sir.
particular study on different percentage of coal bottom or only 1% you selected for this study?
Sir, actually in the in the depth, we have replaced it with different replacement percentage, but here I have shows the only the 100% replaced CBA, 100% replaced natural sand mortar mix results. We have replaced it with 20, 40, 60, 80 and 100, and we have investigated that it's a part of our whole major work.
So up to which percentage you are recommending the utilization of coal bottom in concrete?
Sir, up to
for getting
40% we
optimum
can.
results.
Sir, up to 40% we can replace, considering the thermal behavior, we can replace it up to 40%. But due to the workability and higher water demand, 20 to 25%. If there are application where the workability, water demand is the major thing, then there 20 to 25% is the limitation of that replacement percentage. However, where the applications where the demand is that we want the higher replacement and we want the thermal behavior, better thermal behavior, so up to 40% we can go. We have tested the thermal conductivity test also. So utilization of CBA reduces the thermal conductivity of the mix. So this is one of the more application where we can use the CBA based mortar.
When you tested a specimen for elevated temperature test, you applied some sort of standard curve for temperature application or random temperature, like as you said in your particular
Actually,
experimental
sir,
setup, you have a
yes, sir.
predefined.
Sir,
Or
the heating cooling, sir, based on the literature survey and all that, the heating cooling regime of from 10 to 15 papers, the heating cooling regime and the cooling rate of that 5 degrees Celsius initial, then retaining for 1 hour, then allowing it to cool down at 2 degrees Celsius per minute. So these are taken from after extensive literature survey. On the different cement based material for concrete and mortar, we have taken it from different literature.
so if I'm looking into your mass loss curve, in that
Yes, sir.
particular case, in normal concrete and in your coal bottom concrete, in both specimen, your mass losses increases with the increase of temperature. Is there any
Yes,
reason
sir.
behind that?
Sir, yes, sir. With increase in temperature, with increase
Yes.
with with increase in temperature, the at 200 degrees Celsius, the elimination of water is occurs. So that's why the 200 degrees Celsius, the mass loss is due to that. At 400 degrees
So
Celsius,
that
the
is
mass loss.
applicable in both two cases, if I'm not wrong.
Yes, sir.
That is applicable for both kind of concrete. But if I'm looking into the variation in both concretes,
Yes, sir. It is a
that
mortar,
is
sir. Yes, sir.
increasing in nature.
Yes, sir. So it will increase, sir, because of the. It will increase, sir, because of the decomposition of the cement binder, calcium hydroxide, and hydration products, and also in CBA, the higher one is because of that higher porosity in overall mix, overall specimen. So that's why the mass loss and the higher water content.
Okay. Thank you.
Thank you, sir.
So now the session is open for all for question and answer. Anil sir.
Yeah. Well, Abhishek sir, can you show the last the slide before conclusions?
So 1 minute, sir. Yes, sir. Sir, is my slide is visible?
Yeah, the one before this.
Yes, sir.
Okay. So here, for the two mixes, there
Yes,
is a
sir.
point around 300 degrees Celsius.
Yes, sir.
Compressive strength is almost same because these two
Yes, sir.
curves are crossing each other.
Yes, sir.
I mean, why this reversal of behavior is there? Can you? What could be the reason that can be which can be attributed to this phenomenon?
So just because of the
Because until temperature reaches 300 degrees Celsius, almost 300, slightly
Yes, sir.
above that, NS is below CBA, and after that they cross each other. CBA overcomes this one. Sorry, NS overcomes CBA.
Sir, the lower compressive strength of CBA based mortar is because of its higher porosity. The compared to natural sand based mortar, natural sand based mortar makes specimen has lower porosity, and the porosity bears the inverse relationship with the compressive strength. So because of the higher porosity of the CBA based mortar, the compressive strength is coming lower than that of the natural sand based mortar.
So this indicates during fire, CBA is not good. Means NS is good. Natural
Sir,
one
up
is
to
good.
Sir, up to 400 degrees Celsius, the CBA based mortar is shows the better or the comparable behavior, because up to 400 degrees Celsius, actually, sir, due to the porosity benefited the CBA mortar up to 400 degrees Celsius, because it led to the easy dissipation of the vapor pressure, which develops during the initial 400 up to 400 degrees Celsius. But beyond, sir, 400 degrees Celsius, the negative impact of higher porosity of CBA based mortar overcomes the benefit of that. So porosity, that's why its relationship, its compressive strength reduces compared to that of natural sand mortar.
Okay. And from 600 to 800 degrees Celsius, you can see they are again converging, and it seems like after beyond 800 somewhere they will join again and cross each other.
No, sir, up to at 800 degrees Celsius, the calcium silicate hydrate completely dissociates. So the strength giving compounds completely dissociates. Beyond 800 to 900 degrees Celsius, the specimen loses almost, I don't know, sir, up to 800 we have tested. But in the literature, I have studied that 800 to 900 CSH completely decomposes, which is a strength giving compound. So
Okay.
I don't think so. Okay, they will meet,
Right.
sir. But I have not conducted that, sir. So
beyond 800 tests now. Okay. Right. Thank you. Thank you. Is there any other questions from the audience? Anyone? Okay. Thank you. You may stop presenting now. Now I request Rahul Kumar Minaji to present his paper.
Yes, sir. Good afternoon, sir.
It is paper ID 122, and this paper is contributed by Rahul Kumar Meena, Arituraj, and S. Ambu Kumar. The topic of research is numerical investigation of wind load on side ratio of high-rise buildings.
Yes.
Okay, Rahul Kumar Meena, please start your presentation.
Good afternoon, all. I'm Rahul Kumar Meena, research scholar from Delhi Technological University. My topic of presentation is numerical investigation of wind load on side ratio of high-rise buildings. These are my table of content: introduction and objective of the present study, models and boundary condition. The whole study is being carried out using ANSYS. This is introduction. Actually, we all know that land availability is very less. So we have only option is vertical high-rise structures. And for high-rise structures, the wind load is being very curious to design, and design is based completely on the wind loads basically. So high-rise buildings pressure can be checked using the two techniques. The one is called wind tunnel technique, and the another one is called CFD, computational fluid dynamic. So we have used in this experiment as a CFD, because wind tunnel is very time consuming and very costly and very less availability basically. So we have conducted the study using CFD. Now, this is the objective of our present study. We have to find the pressure contours for different phases so that designer can use the pressure values to design the same building. And we had studied the velocity profile and turbulent intensity profile to validate the result with the wind tunnel studies. And we had discussed the flow patterns around the building. Also, we also find the phase average pressure on the vertical center line of each phases. And mean pressure contour is compared with the Chinese code, because Chinese code have this are building shape in their code. So this is my model in my study, model A. As all the model are L-shaped building, and we had varied the phase C. Here we can see the phase C dimension. Phase C is being varied in all the dimension. Actually, on the side ratio, we had concluded this study, and the domain is used in this study is based upon the reviews at all. According to reviews, this domain is being considered, and the side walls are being considered the free slip walls. Here we can see the free slip wall in all the sides, and the ground is considered the no slip wall, and building here, this building is considered as a no slip. Now this is the inlet, this is outlet, and this is being a domain virtual wind tunnel to conduct this study. Now this is the meshing. We have provided different type of meshing. The one is domain. Domain is provided as a tetrahedron meshing. We had adopted the tetrahedron meshing because to get the earlier result and to use the less computational power. And this is the inflation. Second one is inflation. Inflation is provided because to capture the effect of the wind near the edge of the building. And we have also provided the edge meshing, and the final meshing is provided for the building. It's just to capture the flow as accurately, because computer cannot understand the actual geometry of the structure. So we have provided it in the parts of meshing, and the numerically applied equation are solved in that, particularly in that meshing. Now this is the result of velocity profile and turbulent profile. So as we can see, the turbulent intensity is up to 12%, and this is for terrain category second, and we have considered in this as a terrain category second. And the velocity profile, the green one, is the velocity profile, and this is according to power law. So power law is basically provided for a boundary atmospheric boundary layers flow, because at the above free stream velocity is being achieved at the 1 meter. So this is the we have provided, and we can validate it. And the alpha is the ground roughness. This is for different terrain category. It is different. It is varies in between 0.1332 to 0.167. For our study, we have considered 0.147. Now this is the phase average pressure for all the models, and we can here see that after using this equation CP mean, we calculated the phase average pressure on each phase, and the results are live with the Chinese code, and we can see that phase E and phase F are in the positive for model B and C, where the phase E and F are the larger dimension, and in model A it was in the lesser, and it was in the negative pressure. Here it is in the negative pressure. You can see that. Now this pressure contours we have obtained through the ANSYS CFX, and this is showing that phase A is being positive, meaning windward phase. Here in this we can see the phase A is being windward, and phase A and phase E and F in for model B are being positive, and phase E and F are not positive in this case, meaning they are in the negative. Okay, negative meaning the suction basically. And this is the pressure contour we have provided the values so that designer can use these values at which height what pressure are there. So at phase A we can see that at this center the maximum pressure is on the center, and at the edge the pressure is become decreasing. And in the phase B on this model A, the pressure is being decreasing in the along wind direction. For particularly for all the phases we have provided these values, and we can see these pressure contours. And here this is being compared with for both the models. These are using to validate to get the pressure contours on every phase. These are for model B, where the side ratio is 1:1, being B and C is 2. Okay, here we can see that different type of pressure. Here we can see that for phase E and F, these are being positive, and for phase model A, these are in negative. Now this is pressure control for model C using ANSYS. and these are using for to get the data that at which height what pressure control we are getting, so that we can find the force at particularly at that height. This is the velocity streamline we have provided. The fish is showing the direction of the velocities, and we can see the large vortices are formed behind the model B and model C. These are the vortices. As the height, as the length is being changing, the vortices are being affect, and it's been very large recirculation zone created after model C. For model A, it is very less. So this is being velocity streamline. And these are the vertical center line for every pressure, and for phase model A, we can see that phase A is being only the windward phase is being positive, meaning that is getting the air directly on the windward faces, and on the model A, these are in the negative, meaning that is all the phases are in suction. And for rest of the model, it is being three direction, three phases are being positive, and for model B and C, three phases are positive, three phases are negative. And somewhat same pressure distribution for phase C for both model B and model C. Now we can conclude this is the whole study is being carried out using K epsilon model, because the majority of the research is being done using K epsilon model, as the K epsilon model is calculating the far good result for far away the boundary. And we have concluded the following major findings: the change in the side edge of the building, it affects the suction on the leeward side and side faces of the building model. Phase A always show the positive pressure for all the models, and other faces has a negative pressure, meaning suction they are being affected by the suction. Phase E and phase F of the windward phase has an almost pressure distribution for all the three models. Phase E and phase F का जो हमने pressure distribution बताया वो same है. And the accuracy of the result depend upon the matching of the geometry. As we have provided the geometry after 100 of iterations, after that we have find that at this matching we can get the better results. Bad matching will not give you good results, but a good matching will always give you a good result. And so the accuracy depend upon the matching. And the variation of pressure coefficient on the central line discussed and shown graphically. The phase E pressure distribution affected by the side ratio of the building model, and it is maximum pressure distribution for model C and minimum for model A. Now these are my references for this study. Thanking you.
Well, thank you for presenting your work in this conference. It is a nice work, and you made a good afternoon for.
Yes, sir.
Now, my question is, which model you have used for interaction between air and the structure?
Yes, sir. Which model meaning? The configuration of the building. We have concluded the L shape of the building.
No, interaction between air and structure. There is some interaction between air. This is a fluid structure interaction problem.
Yes, sir.
Fluid is air and the structure is the solid, so it is a fluid solid interaction problem. So which model you have used for this?
K epsilon model.
Huh?
K epsilon.
So I didn't get you. Please repeat.
This K epsilon model. The K epsilon model is used for all the study, because majority of the research is done using K epsilon for this type of problem.
Okay.
May I ask few questions?
Yes, sir. Yes, sir.
Yeah, this is Professor Rajesh Goel this side.
Yes, sir.
So,
Welcome. Let me introduce. He's Professor Rajesh Goel. He's Dean in Kumar Bahadurgarh. He's a very key position. He's a very senior civil engineer faculty.
Thank you, Anil Kumarji. Thank you very much for a nice introduction. So, I have a few basic questions to Mr. Meena. Your work is very good. You see, I have been working in wind engineering from last many years. Of course, not in this mathematical modeling, but wind tunnel testing.
Yes, sir.
So, first question is that always arise when we do such kind of work. That is, how to validate your this mathematical study with wind tunnel studies. Because normally what we do that kind of in such kind of work that we validate some wind tunnel testing with your mathematical modeling. Have you done such kind of work in your this research?
Yes, sir. Actually, I have, but actually the validation is not shown being here. But validation can be done using the Chinese code. The GB50009 is the Chinese code. It's in 2012 version, and that they have provided the L-shape pressure coefficient, which is very close to my studies. Actually, for phase A and for phase C and D, we can see here from this graph.
But in my opinion, you could test any of the wind tunnel data which is available with you or with your supervisor or with anybody,
Yes,
with
sir.
your mathematical model, and
Yes, sir.
just you can establish the relation that whatever being studied in the wind tunnel, the same kind of results you are getting. So once you establish that kind of relation, then you can proceed at, then no such kind of question will arise. That is okay. One of my question was, another question is this thing, why you have chosen the Chinese code? Because Chinese code is not supposed to be very close to Indian code.
Yes,
You
sir.
know this thing, which international code is very close to Indian code? Do you know?
Sir, British code is very close to our code because this almost copied in that.
British as well as Australian also, because many of our data in Indian IS 875 Part 3 has been taken from the Australian code earlier.
Yes,
But
sir.
now it has been revised, so we did our own work on researches and we incorporated many things in that. So
Yes,
anyway, so Chinese, you have some specific reason. I think you are telling that your model is very close to whatever is, yeah.
Yes,
So
sir.
that's why you have taken Chinese code.
Yes, sir.
Okay.
Yes.
Another question is, these all building models are the arbitrary building models, or it is some real life buildings? You have made the model of that building.
Sir, actually from literature I found this L-shape building in because it's very common. Actually, sir, it's very symmetry in both the face. It's symmetry. So I did, actually the study.
Can you relate your this building with any of the existing building? Maybe you are working in NCR, so maybe some building that will give more weight to your work. If you just relate your work with some of existing building, no? I think that will be more, relative or more, your work will be more significant in that case. Okay, so my last question is that is the scale of model. Is there any scale of model being considered in this study, or yeah, please put a
1 is
light.
to 200 is being considered, sir.
That is the geometric scale.
Yes, sir.
There is one more scale is to be considered. That is the dynamic scale or hydraulic scale, like that, depending upon the height of the wind in the wind tunnel, or maybe in your model, mathematical model, that you have not studied.
No, sir. This is not done.
Okay. Anyway, you please keep, because you are a researcher at this stage, so you please keep all these things in your mind, and best of luck for your future work and your thesis work.
Thank you, sir.
Thank you, sir. For next presentation, we are calling. The title of next presentation is Effect of Adding Fly Ash and Metakaolin on Mechanical Properties of Concrete. The paper is authored by S.K. Singh, Maninder Singh and Rajesh Goyal and presented by Maninder Singh. Maninder is here?
No, actually, he is not here. He is my co-author, so I am going to present this paper today. This is
Okay,
Rajesh
sir.
on this side. So I am just presenting this paper with the permission of Chair Dr. Pankaj Kumar and Dr. Anil Kumar. So may I start sharing my screen?
Sure, sir. Please go.
Yes, sir, please.
Hope my screen is visible to everyone. Is this?
No, sir.
Okay, 1 minute. I think now it is visible.
Yes, sir.
Okay, so good afternoon, everyone. Today I'm going to present the effect of adding fly ash and metakaolin on mechanical properties of concrete. The research being conducted by myself, my co-researchers and co-authors, Dr. S.K. Singh and Dr. Maninder Singh. This presentation was supposed to be given by Dr. Maninder Singh, but due to some reasons he is not here today. So I'm presenting on his behalf. So You see, this kind of work, it is nothing new. Only new is that the blend of some materials. We civil engineers, we all researchers are working from past many years on the enhanced properties of concrete. So we tried and tested many, blend of material in concrete. The same kind of work is being done by ourselves. So here we are taking fly ash and metacolin in a partial replacement of the cement in making the concrete. And we just evaluated the compressive strength, split tensile strength, and flexural strength on some model of concrete, cubes of concrete, or cylinder and beams. So this is very basic study. This is orientation of work in this presentation, so I'll not just recite these things. So why this kind of works is arising from last many years? Because we researchers always looking forward to have some alternative construction material. So from past many years, we are using cement as one of the most important binder materials. We cannot, skip the use of cement. Although in present researches, it is being tested and done also, like use of some of alternative this material, geosynthetics and all. So, but using cement with some blend of material like fly ash, GGBS, silica fume, blast furnace slag, or many more, which is called as the supplementary cementitious material (SCM). So by using these all material as the partial replacement of cement is being tested from last many years, and we found very good results. We ourselves did study. Dr. Anil knows it very well. Long back in 2010, in making high strength concrete by use of some of addition of supplementary cementitious material to get M80 concrete. So getting M80 concrete with standard constituents of the concrete is not possible. So we have to alter the material, quality and quantity also to get that high strength concrete. So here the aim was not to get the high strength and all. Aim was to get the concrete very sustainable, or maybe economical, or maybe greener, or whatever. Means in present time we can define this thing in many ways. So one of the thing is also the cost. Like I just discussed, the economy. We want to bring down the cost of our construction, cost of our concrete. So here we substituted in present study fly ash and metacolin. Although the substitute may be the GGBS, fly ash, silica fume, metacolin, rice ash, and the researchers have tested many more materials also in past, and I am sure in future also this kind of research will continue. So here aim, I just discuss what was the aim to find the effect of the partial replacement of fly ash and metacolin in the cement. And here we tested M30 grade of concrete, and fixed water cement ratio was taken as 0.45. Material was, of course, fine aggregate, coarse aggregate, water, fly ash, and metacolin. These are the physical and chemical properties of all the materials, the basic material, cement, fly ash, and metacolin, which was focused in this research, like their chemical composition and their some physical parameters that is listed in this slide. And specific gravity, to be very specific, which is more important, that is for cement we know it is 3.18, fly ash normally in this range, and metacolin is around 2.6. And I think we all know metacolin is not a byproduct like a fly ash. We cannot say metacolin is a byproduct. Metacolin is a product which we produce intentionally by calcination of some of the clays, or calcination of some of the waste material of some of the industries. So straightforward, it is not a byproduct. It is not a waste product like a fly ash, like a GGBS. So here these are the nomenclature we have used, like we gave the nomenclature of various different quality of concrete with the partial replacement of fly ash and metacolin. So we have taken replacement of fly ash 0% to 20% in the increment of 5% interval. Likewise, metacolin also taken 0 to 20% at the increment of 5%. So nomenclature means X digit was for fly ash, M stand for mix, Y digit for the metacolin. So 0M0 means it was a control mix, 0M0. Likewise, it is shown here. Like 0M0, there is no fly ash, no metacolin. So it was, we can say, the control mix where 100% cement, whatever the quantity was calculated in the mix design, that is taken. And 0M5 means fly ash 0, metacolin 5%, 0M10 likewise. So it is very clearly understandable. So water binder water cement ratio was kept very standard 0.45 and variation of the, you see, these all quantities are shown here. Fly ash 0, metacolin 0, cement 100%. Likewise, this all was varied. So we can say maximum we replace 40% of the cement. So here at the last row, it is 60% cement, 20% metacolin, and 20% of fly ash. So maximum replacement was 40%. So because of the limitation of slides straightforward, we can switch to the results. Many of the slides were skipped in between. So here this is a 3 days compressive strength. So main focus was on the compressive strength. So we have taken 3 days compressive strength, 7 days and 28 days, of course. So 3 days compressive strength for all the mix, it is shown here. Extreme right is 0 M0. So you can say it is a control mix, and likewise it is a varying mix. So in 3 days, the control mix was showing 15 megapascal compressive strength. So majority of all of our blend mix are showing more than that. Only barring this one where 0M20 metacolin was 20% and fly ash was 0%. So here it was around, we can say, 14 megapascal. So rest of places you can see the compressive strength shown by the test is more than the control mix. So we can say in all respect it is showing the better results. At 7 day, again it is the control mix showing 20 megapascal. So you can see it is very clearly visible. All blend of mixes are showing more than that. But you can see the highest, if we see, it is 5M10. So 5% metacolin and 10% of 5% fly ash, 10% of metacolin. So you can see here. So if you look at the 28 days, which is supposed to be very standard one, because M30 grade was the mix grade. So control mix was showing 33.84, roughly 34 megapascal, which was well required, well desired for a mix. So only you can see 5M20 is showing a bit less of this value. Rest all are showing again the bigger buildings here. So 5M10 again showing the maximum value 37. So this is a broad conclusion of our study also, that if we mix 5% of fly ash, 10% of metacolin, so it will produce very high results, which is positive in our use. So likewise, flexural strength of the beams, beam of standard size, we know it is 100 into 100 into 500 as per codal requirement. So for standard mix, but it was not taken for all the mix design or all the blend of concrete. So only for particular mixes which was showing good compressive strength, only for them it was tested. And you see here also now we are more focused towards this one 5M10, because 5M10 in last two presentation, last two slide, it was possessing very high compressive strength. So flexural strength also it was showing on the higher side 12.46. And split tensile strength, if we look at, again it is showing the same mix is on bit on higher side. So it is very clearly, visible from all this presentation that this mix is possessing comparatively good strength than the others one. So these all are the conclusion which we have already discussed, like addition of M metakaolin and fly ash increases the compressive strength on all the 7 and 28 days. And here, yeah, this is 5% of fly ash and 10% of metakaolin. That is the optimum mix as per this study, which we have find out. So that's all from my side. So floor is open for discussion and queries. So please, thank you very much.
Thank you, Rajesh. Any query from audience? Sir, I have a very small question, very basic questions. In your presentation, at one point you wrote you are selecting M30 grade of concrete.
Yeah.
Sir, is there any specific reason for selection of this particular grade?
Yes. Actually, based on our literature review, the previous researches where the researcher have not used the blend of material, like where researcher use fly ash or where researchers use metakaolin, many of the places we have found that M20 to M30 grade of concrete was used for their testing. But this is not an again hard and fast rule, because we can when we are doing such kind of research we can focus M20 also, M25 also, but we want to go for the material this mixed design also. So M30, for M30 we have to go for mixed design. So that's why we have chosen this one. M25 or M20 we can use the standard mix also, but our intention was to use the mixed design. So that's why we have chosen, when we are going for mixed design, so we thought better we go for a bit higher grade. So that was the reason, although there is no hard and fast for this thing.
Sir, I have one more query. When
please.
we are adding 5% fly ash and 5% metakaolin, in that case we are getting maximum strength and in 10. But similarly, when we are increasing the percentage of metakaolin, at one point at 15%, the reduction in strength is very significant. Is there any specific reason, sir, as you said?
You see, these all are depending upon the chemical composition whenever we are adding these all material in our concrete. So this, of course, this is another kind of study, means what is the reason behind this. So there is a long-term studies required, because whenever there is addition of this material, we know there is a composition called as calcium silicate hydrate, CaH. These all are produced. So that is the micro study analysis of the concrete. Maybe further study can evaluate why this all is happening. But at present, I told you in the beginning that our focus was just to find out the compressive strength and all. So of course, further study can be done to find out the reasons.
Thank you, sir. Thank you for giving your wonderful, your precious time to us.
Thank you. Any other queries?
Thank you, sir. Thank you very much for presenting your valuable research in this conference.
Thank you.
Audience might have definitely benefited from such a nice presentation. Thank you, sir.
Thank you very much. Thank you, everyone.
Is there any question from audience? Okay. Now I invite Ms. Sakshi Bhatia to present her research paper in this conference. Probably this might be the last presentation of this session, and it will end because I don't think Aditya Tiwari is present for the next presentation, paper number 113. I think he's not there. Okay, Sakshi Bhatti, please present. The topic of her presentation is analytical behavior of concrete filled single skin and double skin tube columns subjected to axial loading. So you have 10 minutes to finish your presentation, followed by question answer session for 5 minutes. Sakshi, please present your screen.
Yes.
Yes, Sakshi, please start.
Good evening to one and all. My name is Sakshi Bhatia, and I'm going to give the presentation on the topic analytical behavior of concrete filled single skin and double skin tube columns subjected to axial loading. The co-author is Aditya Kumar Tiwari. The paper ID is 108. First, I would like to tell you about the content of my presentation, which includes the introduction, scope, objectives, the geometry
Sorry
of
to
the
interrupt you,
columns.
Sakshi. Only slide number 19 is visible on our screen. The reference slide only.
Yes, sir, this is a very common problem many presenters have faced.
Sir,
She might be able
due to the poor connection.
No, it's not due to poor connection. You can run your slides from another window. That is one of the solutions Professor Kumar has suggested. You can share the entire screen instead of sharing a window.
So now is it visible?
Yeah, it is visible. I think you can continue this way also, but be sure to click the slides one by one.
Okay, sir. I would like to tell you about the content of my presentation, which includes the introduction, scope, objectives, the geometry of the composite column, CFST and CFDST, the result and discussion. Then there are conclusion, and in the end there are references. In the introduction, first I would like to tell you about that what is the need of the composite construction. Now we all have seen a lot of structures, whether they are new or old, big or small, but the most fascinating one are the modern skyscrapers, which are obtained from the extraordinary achievements of science and engineering. Also, the construction main focus is being shifted towards the safety aspect of the project along with the economic aspect. And we know that there is a limited land and population explosion has become a challenge in the urban areas. So we need to make taller structures that can provide more space to more occupants. Also, we know that the column at the bottom level of any building, they need more strength and durability to withstand the loads. The composite columns like concrete fill single skin tube columns and concrete fill double skin tube columns, they provide us with such advantages of high strength and durability. The composite columns, they are structurally combined together to have the benefits of both the materials, steel and concrete. As we know, the steel is good in tension and concrete which is good in compression. The main topic is what are the CFST? It means the single skin tube column, concrete single skin tube column. It consists of a hollow steel tube which is filled with the plain concrete or with reinforced concrete, and the steel reinforcement, the steel tube present in the CFST, it provides the confinement to the concrete, which helps to increase the load capacity of the columns. The most used layouts of the CFST are shown in the figure. The black outer line is showing the outer steel tube, and the gray part is showing the concrete infill. The CFST are highly used in the high-rise building and multi-story buildings for columns and column beams, and as beams in the low-rise buildings. They have the advantages of great seismic resistance with great strength and high flexibility with good energy absorption capacity. The concrete filled double skin tube columns, as the name suggests, it have two skins, two tubes of the steel. In between them, there is concrete infill. The CFST, they are known for their higher earthquake resistance than the CFST segments. The strength of the CFDST segment, it is mostly affected by the concrete compressive strength, whether it is increasing or decreasing, the steel tubes yielding strength, the diameter to thickness ratios of both the inner tube and the outer tube. The circular, it is proven that the circular cross sections are the one which have the highest confinement effect. The CFST, they have been used in as piers for bridges in Japan and as electric transmission poles in China. The following figure, they are showing the most common layouts of the CFDST columns. The outer black part is showing the outer steel tube, and the inner black part is showing the inner steel tube, with the gray part representing the concrete infill. We can also say that the CFDST is a modified CFST with a sandwiched concrete. The scope of the study, as I have earlier said, that there are many advantages of CFST and CFDST because of their greater resistance to the axial load even after they are exposed to fire or seismic forces or impact loading. They have application in variety of construction projects, like they have like columns which are supporting the offshore structures in the roofs of the oil storage tanks, in workshops, and in bridges as piers, and also as pile-in foundation. So the main objectives of the study is to analyze the axial load behavior of both the columns, that is CFST and CFDST. The parameters which were considered to evaluate the axial load behavior are the diameter to thickness ratios, the segment shape, concrete grade, and steel yielding strength. And the other aim is also to identify the best composite form of the columns out of the two, that is CFST or CF.
You're not audible, Sakshi. Are you there, Miss Sakshi? Are you there? Well, I think she has lost the connection. In morning also she had some problem with the internet. So let's wait for 1 to 2 minutes.
Answer, I think she's having bad internet connection.
I'm trying to contact her, sir. If let's wait for only 2 minutes.
Okay.
Dear all, I have asked the co-author of Sakshi Bhatia to connect to her. I think within a minute we will get his response. So if we don't get some response within 2 minutes, we'll end the session. We pardon for the inconvenience caused to you. Well, Dhirul, she's unable to reconnect in spite of trying so many times. So I think we have no other option but to manage with as much as she presented. What do you say, sir, Pankaj, sir?
Yes, sir, it's right. It's time to conclude, sir.
Right, sir. Thank you very much for being here and sparing time to present your work in this conference. It was really a wonderful day with a very good range of research is presented in this session, ranging from sustainability approaches to buildings, as well as wind effects on buildings, then coming out with new materials by replacing cement with other materials, and also a very senior from the field of civil engineering have joined us today. Like I thank especially Professor Rajesh Goyal and Professor Rajan, and I'm sure that audience might have benefited from the views they have shared, and they will look into further research in their respective areas. Thank you very much. Anything anyone would like to share as a feedback how the sessions were conducted? Although not many people are here right now, there were around 20 plus participants today during the day. Almost 14 papers have been presented out of 15. Only one was absent. Well, thank you very much. Pankaj sir, you want to say something?
Okay, thank you everyone. Thank you JUIT for conducting a wonderful conference. Especially thank you to the Department of Civil Engineering JUIT. And
Professor Rajesh, would you like to share some your views, sir?
Yes, Dr. Anil, Kumar. At the outset, I congratulate all the organizers from JUIT side for conducting a wonderful, this international conference, which is much needed at present time when we are sitting at our respective homes. This is the best utilization of the time, I think. So all credit goes to JUIT team, especially Professor Gupta, Professor Ashish Kumar, who got the HOD charge now, and Professor Gupta got the charge of deanship. I recently came to know. I congratulate both of them. Then all the efforts being imparted by Dr. Sourav Rawat for conducting this wonderful conference, which is a flawless, in my opinion, because I am also attending many conferences here and there. But many of time I have observed there are many flaws during their conducting. But here I have observed it is really wonderful, very nicely planned and placed here across all the participants. And like Dr. Anil rightly said, out of 15, 14 paper has been presented here. This is a good success rate for any of the conference. So thank you everyone, and once again I congratulate to team JUIT. Thank you very much.
Well, thank you, sir. HOD Civil Engineering, Professor Ashish Kumar is also here. Would you like to say something, sir? Well, I believe he might be away for a while. Well, thank you. Then here we can conclude the session. If any of the participants want to share their views, they can do it right now.
Yes, sir. I just want to share some views.
Oh, okay, sir. Right,
yes.
Sir. Rajan, sir, please.
So first of all, let me congratulate the Department of Civil Engineering from JUIT for organizing such a informative conference, and the support given to the authors was also good from the organizer side. And the paper presented in the sessions were really outstanding and were having the good qualities. So we attended yesterday and today also. So we find good quality of papers are presented, and good novelty was there regarding each and every paper. And definitely we learn many things from your platform, that your conference. Questions were asked by you were relevant and informative, and definitely we could or we will come with good initiatives in the area of research in the uh, materials and sustainable materials in the civil engineering. So I'm very thankful to all dignitaries who are present here: Dr. Pankaj Kumar, Rajesh Goel sir, then Anil Kumar sir, Jha sir, Ashish sir. So thank you very much for giving us the opportunity for being with you and sharing our little research with you. So thank you very much, sir.
Thank you, Rajan sir. Thank you so much for being here today.
Welcome, sir. Welcome. So definitely we will be in contact, sir. So I have noted the mail ID and contact number of Rajesh sir, Anil Kumar sir, then Pankaj Kumar sir. We will be in contact so that we can contribute in the research and community of civil engineering.
Yeah.
Dr. Anil, I think you can request for switching on the video for every participant just to have a snapshot.
Yes,
so
yes.
that it can be used in conference, promotions and all.
Right. Correct. So I request everyone to please switch on their cameras for a few seconds so that we can take the screenshot. Well, if you are comfortable, please do it right now. Kaushal sir is also there.
Hello, Anil sir.
Hello, sir.
Anil ji, new outlook.
Sir.
We wish to see Dr. Ashish Kumar also, if he is available right now.
I think, sir, he went
He is not
to
around, I
other
think.
meeting that
Okay.
organizational function.
Dr. Saurabh Rawat, if he is available. Dr. Salil Jha. Okay. So at least whoever is available, we can have some snapshot. Okay. Thank you very much, everyone.
Thank you, Anil sir. Thank you, Rajesh sir. Thank you, Ashish sir, Rajan sir. Thank you, everyone.
Thank you, sir. Thank you so much.
Thank you, sir. Thank you, everyone, sir. Thank you.
I think, Anil sir, it is a time for
Yes, sir. We'll log out from here and then we will join the valedictory.
Yes. At 5 p.m. we can join the valedictory.
Okay, sir.
Right,
so
sir.
Shall we log out from here?
Bye.
Okay, stay home, stay safe, everyone. Enjoy your time.
Thank you, sir. Thank you very much.
Thank you very much.